Hey everybody! Today we're going to be applying the law of cosines through two different examples. So I'm just going to go ahead and write up the law of cosines, which is c squared equals a squared plus b squared minus 2ab, the cos of big C. Where does this come from? Well, let's just go ahead and draw a triangle. So I'm just going to draw some arbitrary triangle here. And in this triangle, we are going to label it A, B, and C. And once again, our opposite angles to our sides will be big A, big B, and big C. Now, the law of cosines is used specifically when we know two sides and the angle in between them. When we know two sides and the angle in between. And this is known as the SAS, side angle side. Or as one of my students so eloquently put, a side angle sandwich. And you can't see me right now, but I am face palming just a little bit. But I loved it all the same. So we have side angle side. And we know those, and we are looking for some other side. Alternatively, also can be used when we know all three sides. So there are two examples of a law of cosines, and we're going to work through both of these examples, and then hopefully all of this is going to make sense. So scrolling up, and we're going to get ourselves a little triangle here. So let's go ahead and just draw some triangle. It doesn't matter what it looks like, is totally arbitrary. If you've watched any of my other videos, none of my triangles are ever drawn to scale. We have 10, and we have 12, and we'll say this is 100 degrees, and we are looking for x. We start off with the law of cosines. C squared equals a squared plus b squared minus 2ab, the cos of C. C is always the known angle in between the two sides. So here we have a law of cosines example because we know two sides and the angle in between them. That's the flag for using law of cosines. The little c will be our unknown side. In this case, x. So let's go ahead and fill these in and see what we get. Our x squared will equal, well, which one is a, the 10 or the 12? It turns out it doesn't matter as long as you pick one. So typically I pick the smaller one for a, but it doesn't matter. It could be 10 or 12. 10 squared plus 12 squared minus 2 times 10 times 12 times the cos of 100 degrees. And make sure your calculator is in degrees mode. I'm going to go ahead and clean this up just a little bit to show my steps. So we have x squared equals 100, that's the 10 squared, plus 144, that's the 12 squared, minus 240, multiply those together, cos of 100 degrees. Be mindful, I've seen the error made where people will do 100 plus 144 and subtract the 240 and then hit enter. It gives you weird answers. Remember that this 240 is multiplied by the cos 100. So you can go ahead and put this into your calculator as is, just like that. You could have done it in the step above if you're feeling comfortable, and you're going to end up with something that's about 285.7. We want to get x though, not x squared, so we take the square root of both sides, and it's going to leave us with x equals about 16.9. In this triangle, it was unitless. If this had been meters or kilometers or inches, you'd have to use units. But in this case, we are done with x equal to 16.9. And that is how you solve an unknown side using the law of cosines. Let's go ahead and do this again, but we're going to solve an unknown angle. We have some triangle. Totally arbitrary triangle. We just drew some triangle. And we're going to go ahead and label it 7, 10, 13, and theta. We have our law of cosines equation. C squared equals a squared plus b squared minus 2ab times the cos of c. The number one mistake that I see folks make here, they think that little c is the biggest side. They fill in 13 for little c. That is not the case. Little c has to be the side opposite the angle that we're looking for. So in this case, even though our little c, 10, is not as big as 13, it's the side that is opposite theta. Little c, big C. If our big C is theta, then the little c has to be what's across from theta. So we're going to fill in what we know. 10 squared is equal to, a and b doesn't matter. Pick one, stick with it. 7 squared plus 13 squared, as long as they're the other two sides, minus 2 times 7 times 13 times the cos of theta. We're going to clean it up. 100, that's just the 10 squared. 7 squared, 49, plus 169, minus 182 cos theta. Pause again. Remember in that first example where I said I always get nervous that folks will add, and subtract and turn that into a number? It's even more important on this one, because if you try and subtract that 182, it's not really a 182. It's a 182 cos theta. That's a coefficient. We're going to have to deal with that later. So to get theta all by itself, we have to start off by subtracting 49, subtracting 169. We'll do that from both sides here. It's going to leave us with negative 118 equals negative 182 cos theta. Do not, I repeat, do not be that person that adds 182 to both sides to get rid of this negative 182. It is a coefficient. To get rid of something that is multiplied by an unknown, we must divide. Divided by negative 182. When you divide it by negative 182, it's going to leave us with cos of theta equals approximately 0.648. We're almost there. We're almost there. To finish this off, you're going to have to use the inverse cos. Theta is equal to the inverse cos of 0.648, bringing us home our final answer. Theta equals 49.6 degrees. And that is how we can use the law of cosines in order to solve an unknown angle when we know all three sides. Thank you very much, and I hope to see all you clever little cupcakes next time.